Laplace transforms. Introduction to Laplace transform and standard results.
Hello future engineers and my dear students, welcome back to Mudassar Academy. I am Mudassar Sheikh. As many of you requested, so today I am going to start with a brand new, very interesting and a very important topic in engineering mathematics, that is Laplace transforms. See, this topic Laplace transform is seen as difficult by many engineering students, and even those who try to understand it sometimes makes mistakes in examination and end up losing marks. So don't worry, I am going to make this topic very super easy for you so that you can understand it in a very easy manner. And at the end of the series, I guarantee you that you will be able to solve any problem in Laplace transform and score good marks in this module as well as in a final examination. So in today's video, we will cover some basic formulas using Laplace transform, standard results and how to apply them, a few simple problems to build your foundation in Laplace. So stay tuned, don't skip any part of the video, watch till the end and see for yourself how easy Laplace transform is. And if you are new to this channel, then hit the subscribe button right now, ring the bell icon so that you stay further updated on the series on Laplace transform. So now let's start Laplace transforms. So actually what is Laplace transforms? See, Laplace transform is a technique used to convert functions from time domain. So what's the time domain t to frequency domain s. That is, when I convert from t to s, we Laplacize it. Okay, the answer will be in form of yes. So this technique, it simplifies complex differential equation into a simple algebraic equation which can be solved in a very easy way. So we use this method in electrical circuit analysis, in control engineering, in digital signal processing and many other applications. So as discussed, Laplace transform is nothing but transforming a function of time f of t to a simple frequency domain s. So based upon this, we have the formula of general formula for Laplace transform as Laplace of f of t equals to 0 to infinity e is to minus st into f of t dt. This is the basic formula of Laplace transform. Now, based upon this formula, there will be some 2-3 questions we will be solving in the next classes, but we will use this formula, this basic formula of Laplace, that is Laplace f of t is equal to 0 to infinity e raised to minus f of t dt, st f of t dt, to derive some standard results. And these results we will be using to solve the problems in Laplace transform. I will be writing down all the results here now. See them carefully and you need to memorize them. Okay. So the first result is, see here carefully, Laplace of A is A by S. What does it mean? If the question has what is A? A is a constant. So if I tell Laplace of 3, what's the answer? 3 by S. We are doing nothing here. The question given is written in the form of yes. So the Laplace of A is derived as Laplace of A is equal to A by S. So 3 is 3 by S. Laplace of 5 is 5 by S. 10 is 10 by S. Alpha is alpha by S, so on. So if they give Laplace of constant, what's the answer? A by S. Next, Laplace of e raised to 80 is 1 by S minus A. So when the question is having Laplace of e raised to 80, say e raised to 3t for example, or the answer 1 by S minus A. So e raised to 3t will be 1 by S minus 3. That's it. So I'm simply replacing the A value here. We are not doing any complex stuff here. It's very simple. Memorize the formula. In the answer, put the A value. That's it. Okay. Next, Laplace of e raised to minus 80 will be 1 by S plus A. E raised to minus 40 will be 1 by S plus 4. Okay. Next, Laplace of sine 80 will be A by S square plus A square. So is that if the question is find the Laplace of sine of 3t, say what we are doing here? A is 3, sine 3t, A is 3. What is the answer? A by S square by S square. So Laplace sine 3t will be 3 by S square plus 3 square, that is S square plus 9. So Laplace of sine 3t will be 3 by S square plus 9. As simple as that. Next, Laplace of cos of 80 will be s by a square plus a square. S by a square plus a square. So, Laplace of cos 40, say, what is a? 4. S by a square plus 4 square is 16. That's it. Laplace of cos 5t, s by a square plus 25. That's it. Pay attention to what I'm saying here. Next, we are done with sine and cos. Now the other function is sine hyperbolic at. See, Laplace of sine hyperbolic at is, there is a difference between sine and sine hyperbolic. A by a square minus a square. So, sine hyperbolic 3t. So, what's the answer? You can easily tell now. Hyperbolic 3t is 3. 3 by a square minus 9. Okay. Similarly, Laplace of cos hyperbolic at will be s by a square plus minus a square. Okay. See, very simple to remember here. When they use Laplace of only pure sine or cos, listen carefully. Sine or cos, the denominator is always a square plus a square. For sine, the numerator is a. For cos, the numerator is s. If they give hyperbolic, the denominator is always a square minus a square. So, for cos, it is s by square minus a square. For sine hyperbolic at, a by square minus a square. For plain sine and cos, denominator always a square plus a square. For hyperbolic, denominator is always a square minus a square. For cos, numerator is s. For sine, numerator is a. That's it. Okay. And the last one is Laplace of t raised to n. So, this is used when the question is like, say, t square, t cube, so on. Okay. So, the formula is n factorial divided by 60n plus 1. Here, remember, t raised to n is equal to, Laplace of t raised to n is equal to n factorial by 60n plus 1 is used when n is a number 1, 2, 3, 4, so on. And one more here, t raised to n is equal to gamma n plus 1 by s raised to n plus 1. This we use when n is a fraction. Say 1 by 2, 3 by 2, 4 by 2, 5 by 2, 7 by 2, minus 3 by 2, so on. So, here n is a fraction. Let us say 1 by 2, 3 by 2, minus 5 by 2, 7 by 2, so on. Okay. Now, you will be wondering what is gamma. So, gamma functions you have studied in your integral calculus. If you haven't, go to the video on integral calculus and check it, you will find all that. But you don't need that complex stuff. Only here, you need to find the value of gamma when n is a fraction. For that, you need to only remember three simple relations here. One is, we have gamma right here. Gamma 1 by 2 is always equal to what? Root pi. If n is positive, then if n is positive, then we write gamma n. How to write gamma n if n is positive? It's n minus 1 gamma n minus 1, a recurring fraction. If n is negative, then we find the value of gamma as gamma n plus n by n. That's it. Don't worry, I will show you this while solving problems. So, you need to find for this Laplace transform t raised to n is gamma n plus 1 of s to n plus 1. To find the values of gamma, you need to remember this basic relations. That's it. Okay. So, how easy it is, you can see it to yourself. So, again I repeat, a is a by s, Laplace of e raised to it is 1 by s minus a, e raised to minus 8 is 1 by s plus a, Laplace of sin 8 is a by square plus a square, and cos 8 is s by square minus s square plus a square, Laplace of sin hyperbolic 8 is a by s square minus a square, and Laplace of cos hyperbolic 8 is s by square minus a square, and last one t raised to n, Laplace will be n factorial by s raised to n plus 1, where n is a number. And if n is a fraction, then you have Laplace of t raised to n is equal to gamma n plus 1 by s raised to n plus 1. And to find gamma, we have these relations. You need to memorize it. That's all. Okay. So, very, very easy. You can do it in hardly 5 minutes after. That's it. Now, we know the standard results here, which you need to memorize. Although these results The standard results are required to solve problems in Laplace transform. Without this, you cannot move ahead. But apart from this, these are standard results. But the question given may be standard or may not be standard. Okay, so the question given, if the question is not standard, it needs to be converted in the standard form, and that standard form conversion, you need to remember the basic formulas which you have been learning in 11th and 12th grade. Don't worry, I will write this formula for you. So together with these formulas, you can easily solve problems in Laplace. So the basic relations are, we can write a raised to t is equal to e raised to log of a into t. So if they give any problem, in a problem they give 3 raised to t. So how to convert? Standard form, 3 raised to t is written as e raised to log of a into t. Then we have sine hyperbolic at is written as e raised to at minus e raised to minus at whole divided by 2. We have cos hyperbolic at is equal to e raised to at plus e raised to minus at whole divided by 2. I hope you know these relations. These are basic relations in mathematics. Then we have cos square t is equal to 1 plus cos 2t by 2. Note that not only in here, in any mathematics wherever cos square is given, cos square is not standard, while cos sine everything is standard. So wherever cos square is given, you have to always write cos square t is equal to 1 plus cos 2t by 2. These are all trigonometric identities. Then we have sin square t is equal to 1 minus cos 2t whole divided by 2. Then the other formulas are sin a into cos b is equal to half sin a plus b plus sin of a minus b. Okay, then we have say cos a into cos b equals half cos a plus b plus cos of a minus b. There is one more, that is sin a into sin b. So sin a into sin b will be half cos a minus b minus cos of a plus b. But sometimes they won't usually ask this, but you better remember it. So we have one more relation, that is sin cube t is equal to 1 by 4 3 sin t minus sin of 3t, and also lastly cos cube t is equal to 1 by 4 cos 3t plus 3 cos t. So apart from this basic standard results, you need to remember all these formulas to solve the problems in Laplace transform. These are basic formulas we need to remember. Although in the VTU examination they will give formula sheet, but sometimes it becomes difficult to extract the formulas from the formula sheet. So it's better it will take some time, memorize them. It will be useful in the further courses also. Okay. So that's all for today's class. We have seen how using the basic formula of Laplace, we write down all the standard results. So these results need to be memorized along with these formulas to solve the problems in Laplace. So what I need you to do is write down this whole results and the formula 3 to 4 times on separate sheets of paper and memorize them. The next video is going to be very interesting. I will be solving basic problems on Laplace transform which can be asked in the examination. Okay, so if you understand those problems perfectly, then you will be able to move ahead in the further properties and other things. So don't miss the video. If you haven't subscribed, hit the subscribe button and hit the ring icon to stay updated on further series on Laplace transform. If you have any comments, please drop in the comment box below. Share with your friends as much as possible. Till then, see you in the next video. Happy learning. Stay Laplaceized. Bye.